On behalf of the Nebraska Board of Public Roads Classifications and Standards, welcome to this presentation. This is one in a series of videos, the purpose of which is to provide information on the Board's county roads and municipal street standards. Reference Nebraska Administrative Code Title 428, Chapter 2. The topic for this segment is minimum design standards for bridges, non-buried structures, and culverts. It is addressed in two videos. This is the second of the two. As mentioned in the Bridges and Structures video Part 1, other videos in this series cover the learning objectives shown on this slide. Some of the other videos should be viewed and understood before watching this video on Bridges and Structures. That includes the Bridges and Structures video Part 1. In this two-part series of videos on bridges and structures, definitions, notes, and 3R requirements specific to bridges and structures will be covered. Of those three, Part 1 covers definitions and introduces the two notes 18 and 19 that address the two design criteria for bridges and structures, clear bridge width and design structural loading capacity. This video, Part 2, will go into more depth on clear bridge width and its associated note 18, address other notes, and also provide a summary of 3R requirements for bridges and structures. This two-part series of videos also covers other learning objectives specific to bridges and structures. Of the learning objectives shown, Part 1 discusses and demonstrates how tables in the minimum design standards work for bridges and structures and introduces the two design criteria for structures and the basis of their values. This video, Part 2, gets into more depth on Note 18 and clear bridge width, addresses how work on a roadway and work on a structure can affect one another, and also addresses low water stream crossings and fords. The next segment is about 3R requirements. The scope of 3R work will be contrasted and compared to new and reconstructed work and to maintenance work. In the standards tables, starting on page 55, the two columns on the right are new and reconstructed and 3R. This slide shows the boundaries between new and reconstructed, 3R, and maintenance for bridges, structures, and culverts. Starting in the left column with maintenance, you see various activities as defined in 428 NAC Chapter 2, Section 3, the minimum maintenance standards. An example is replacement of rotted timber piling with steel piling. Note the phrase, nothing extensive or costly, per 428 NAC Chapter 2, Section 3, subsection 1C5 on page 89. It is subjective but essentially prevents a structure from being rebuilt without being brought up to standards. Going over to the right column, new and reconstructed typically means that the structure is replaced in its entirety, including an in-kind culvert replacement, or it could be adding a jump span. The middle column is 3R, which is any scope between the right and left columns. This may include widening, redecking, updating bridge rail, and culvert extensions. Although 3R work extends the life of a structure and possibly makes it safer, it is considered an interim measure. State Statute Chapter 39, 2101 requires roadways and bridges eventually to be brought up to reconstructed standards. Quite often, however, reasonable financing is difficult to come by. Finally, the 2016 standards do allow an additional activity that needs to be added to the maintenance column. See Note 20 on page 54, which allows an in-kind replacement of a superstructure for a timber bridge with a national functional classification of local and ADT fewer than 400 vehicles per day. This will be discussed later in the video. This slide shows the basis for minimum clear bridge width values shown in the tables. The clear bridge width is based on the appropriate minimum lane width in the same table, assuming a two-lane road, and is calculated based on the formula indicated in the table for each value. These are the formulas from Note 18 on page 53. Note that the clear bridge width is based on the approach traveled way width. It is important to understand the basis for clear bridge width values in order to identify the correct minimum standard clear bridge width, just in case you have a different situation than assumed in the tables which is a two-lane road with standard lane width. It is also important to use the planned travelway width and the planned shoulder width in the case of Formula A when calculating the clear bridge width, especially if the planned width is greater than the minimum width in the standards. Finally, just a note that formulas E and G apply mainly to bridges using urban area standards. For new and reconstructed work, the clear bridge width is based on formulas in the AASHTO Green Book. This slide shows one of the tables from the AASHTO Green Book as an example. In this slide, the appropriate formulas from Note 18 are indicated on the right side. You will notice that for rural bridges, the AASHTO Green Book does not go less than 2 feet each side plus the traveled way width. For 3R work, the clear bridge width is based on formulas in the Transportation Research Board Special Report 214. In this slide, the appropriate formulas from Note 18 on page 53 are indicated on the right side. Note how Special Report 214 expresses widths differently than the AASHTO Green Book. Plus 2 feet means 2 feet total, not 2 feet each side. As mentioned previously in this presentation, for urban area new and reconstructed curbed sections, the minimum clearance from the edge of the traveled way to the nearest vertical roadside element is 1.5 feet. This is based upon FHWA's Mitigation Strategies for Design Exceptions dated July 2007, page 64, Lateral Offset to Obstruction. Basically, it is a shy distance. Shy distance is an estimated distance average drivers tend to move away from or shy away from an object or obstacle. In this case, drivers would tend to shy away from the bridge rail toward the center line or toward the adjacent lane. The state also uses 1.5 feet as the basis for their state highway standards minimum. For 3R work done under urban area standards, the Board of Public Roads decided to use 1/2 foot as a minimum clearance from the edge of traveled way to the nearest vertical roadside element on a structure. This is consistent with State Highway Standards Note G on page 10. The clear bridge width cannot be less than the values shown in the minimum design standards tables. They may need to be more, but cannot be less. There is only one exception to this and will be addressed later in the presentation. As a reminder, the minimum clear bridge width for any new and reconstructed structure using rural area standards is 24 feet. This slide shows an example where the minimum clear bridge width is greater than the value indicated in the table. For this rural area table, Table I on pages 67 to 68, the clear bridge width values on page 68 are based on lane widths for the 50 mph design speed. For this case, the lane width in Table I for fewer than 400 vehicles per day is 10 feet. The table is based on a 2-lane road, therefore the minimum traveled way for the 50 mph design speed is 20 feet. The clear bridge width according to Note 18, Formula D on page 53, which adds 2 feet to each side, is 24 feet, and this is exactly the minimum value shown in the table. If the design speed is 55 miles per hour, the minimum lane width is 11 feet. The minimum traveled way for the 55 mph design speed is wider, 22 feet versus 20 feet. And the clear bridge width likewise is wider, 26 feet versus 24 feet. If there is a relaxation of standards for clear bridge width in this case, for the 55 mph design speed, it must therefore be based on the larger clear bridge width value of 26 feet. This is another example of how a minimum clear bridge width can be greater than the value in the table. In this case, it is caused by 2 additional lanes for a total of 4 lanes. The values in the tables are based on a 2-lane roadway. If there is a relaxation of standards for clear bridge width in this case, it must therefore be based on the larger value of 47 feet. Note that additional clear bridge width may be necessary if a median, shoulders, auxiliary lanes, or sidewalks are being carried across the structure. The first video, Part 1, presented an example of how to find the table that applies to a hypothetical bridge replacement project. The example assumes 11-foot driving lanes and 2-foot shoulders. Thus, the traveled way is 2 times 11, or 22 feet. As a reminder, Table J on pages 69 to 70 applies rural area standards to roads with a national and state functional classification of local. The minimum clear bridge width, shown on page 70 for the under 400 vehicles per day group, is 24 feet, but we did not check the formula in Part 1. Knowing more about Note 18 and how the tables work for structures, let's determine the minimum clear bridge width based on the formula. Formula D is required for the under 400 vehicles per day group. Formula D from Note 18 on page 53 requires a minimum of 2 feet each side to be added to the planned traveled way. The planned traveled way width is assumed to be 22 feet in this case. Adding 2 feet to each side results in a 26-foot minimum clear bridge width. Thus, the minimum clear bridge width is 26 feet, not the 24 feet shown in the table. As mentioned previously, there is one exception to the rule that no clear bridge width can be less than the value in the table. It pertains only to 3R work on structures. The standards allow the minimum clear bridge width value to be less than the value in the table under the following conditions. The clear bridge width value is calculated using the formula indicated in the table, is based on the minimum 3R lane width in the table, and results in a clear bridge width at least as wide as the planned traveled way. The reason for this exception is that there are more variables that determine 3R lane widths, those variables being percent heavy trucks and whether the road or street is paved or unpaved. The 3R clear bridge width values in the tables are generally based on the more conservative lane width. The Board of Public Roads felt it wasn't practical to list all of the different combinations. Therefore, this exception is allowed. This slide is an example of the 3R clear bridge width exception. In this case, the value in the table is based on a 22 feet approach traveled way. However, because the heavy truck percentage is less than 10%, the minimum traveled way is allowed to be 20 feet. Therefore, a bridge or other structure with 3R work is allowed to have a minimum 20 feet clear bridge width. This is less than the value shown in the table, and it is allowed by Note 18. This slide shows 2 other requirements in Note 18 and 1 recommendation. The first bullet: paved shoulders must be carried over the structure. This could result in a higher minimum value for clear bridge width than calculated by formula or shown in the table. The second bullet: auto gates must be a minimum 18 feet clear bridge width. The third bullet: the desirable clear bridge width for rehabilitated bridges is the new and reconstructed clear bridge width. It may be that a cost analysis would bear this out. This is a recommendation only and not a minimum requirement in the standards. Rehabilitated bridge is defined as replacement of the entire superstructure of the bridge. There may be a misconception that standards for roads and bridges are 2 mutually exclusive separate standards. That way of thinking is not correct. With notes 18 and 22 on pages 53 and 54 respectively, the board provides requirements which coordinate roadwork and bridge work. Note 6 at the bottom of page 47 may also come into play in deciding a scope of work. Work on a road could result in work on a structure, and work on a structure could result in work on a road or street. The following slides discuss this. An important issue that is addressed by notes 6, 18, and 22 is segmentation, that is, doing projects up to a structure or just short of a structure and not addressing the structure itself. Thus, the structure is not updated to standards as it needs to be. Roads and bridges are not in separate worlds. In fact, they are part of the same experience for drivers who have expectations of compatibility, consistency, and safety. So when putting together your 1 and 6 year program of work, plan wisely so a key part of your transportation system is not ignored. The purpose of this slide is to let you know that the Board of Public Roads wants to avoid the bridge being a constriction in the road or street, such as you can see in this aerial photo. The road is wider than the bridge. The Board of Public Roads desires that, with respect to geometrics, bridges and roads be compatible and consistent. Generally, if the road or street is built to minimum new and reconstructed standards, the bridges and structures on the roadway should also meet minimum new and reconstructed standards. And if the roadway meets minimum 3R standards, bridges and structures on that roadway should also meet or exceed minimum 3R standards. The table on this slide shows what minimum standards apply to structures when work more than maintenance is done on at least one of the approach roadways. Referring to the first line in the table on the slide, generally the bridge or non-buried structure must meet minimum 3R standards. Of course, if the type of roadway work is reconstructed, it is desirable for the bridge to also meet new and reconstructed standards for clear bridge width in order to be consistent with the roadway. However, the Board of Public Roads in Note 18 on page 53 allows some flexibility. If the bridge is in good shape and has some life remaining, the Board does not expect a relaxation of standards request unless minimum 3R standards cannot be met. The decision to replace and the subsequent liability lies with the county or municipality. Referring to the second line in the table on the slide, if the type of roadway work is 3R and the traveled way or paved shoulders are widened, the structure must meet minimum 3R standards. Referring to the third line in the table on the slide, if the traveled way or paved shoulders are not widened with 3R work, then the Board would not expect a relaxation of standards request unless a cost-effective analysis per Note 6 shows that it would be beneficial for the structure to meet 3R standards, and for some reason 3R standards cannot be met. The table on this slide shows what minimum standards apply to the approach road or street on either side of a structure when work more than maintenance is done on the structure. Referring to the first line in the table, the Board of Public Roads in Note 22 does allow for some flexibility for very low volume roads, ADT fewer than 400 vehicles per day, where rural standards apply. For those roads, some design criteria need to meet minimum new and reconstructed standards only if a cost-effective analysis indicates it. Referring to the second line, if the work on the structure is 3R and the clear bridge width is increased or a culvert extended, the roadway must meet minimum 3R standards if a cost-effective analysis requires it, per Note 6. Referring to the bottom line in the table, if the clear bridge width is not increased, work on the approach road or street would be to minimum maintenance standards, unless for some other reason the scope of work on the approach road or street requires a higher standard. Finally, although it is not included as a line in the table, if the type of work is new and reconstructed for the structure, the approach road or street should also meet new and reconstructed standards in order to be consistent with the structure. Let's look at Note 22 in more detail. It addresses approach roadway requirements for structure replacements on very low volume roads where rural standards apply. Note 22 implies that the approach roadway on either side should meet new and reconstructed standards if the type of work for a bridge or structure is new and reconstructed on roads with an ADT of 400 vehicles per day and greater. Considering the 60 to 70 year lifespan of structures, it might make sense to correct deficiencies such as a substandard vertical curve or a horizontal curve that is too sharp. Remember, State Statute 39-2101 requires roadways eventually to be brought up to reconstructed standards. Note 22, however, allows some flexibility in the standards for very low volume roads less than 400 vehicles per day. For structure replacements on very low volume roads less than 400 vehicles per day, if there is no significant relevant crash history, the Board of Public Roads does not expect any requests for relaxation of new and reconstructed standards for the 8 criteria listed on the slide. Note 22 potentially allows lower project costs for very low volume roads that do not have a significant relevant history of crashes by not requiring full new and reconstructed standards for some criteria. However, a cost-effective analysis is required for the 8 listed criteria, and therefore improvements may be required by the standards depending on the outcome of that analysis. Note 22 may be most appropriate and applicable if the grade is the same or approximately the same before and after the work. Use good judgment. It may be best to make an improvement even if standards do not require it. It is important to consider safety continuity and consistency with respect to driver expectation. Keep in mind State Statute 60-6,190, which requires a minimum 35 mph posted speed limit in rural areas. Also, the roadway must have proper signage. Considering the lifespan of structures, it might make good sense to not have a potential liability out there for the next 60 to 70 years. Remember, these are minimum design standards. This slide is a summary of the previous several slides to have all of the information on one slide as to when road or street work causes work on a structure and when work on a structure causes work on a road or street. Let's go through each row in the table. In the first row, the scope of work on a road or street is assumed to be reconstructed. It is desirable that structures also meet minimum new and reconstructed standards, but the board did not want to require replacing good bridges or structures prematurely, so the requirement is to meet or exceed minimum 3R standards. However, if there is a significant crash history related to clear bridge width, a safety improvement to widen the bridge should be considered. And if there is a need to widen the bridge, it may be cost-effective to just replace it. There is flexibility in the 2016 standards, but along with that comes responsibility to do a good job analyzing the situation in the pre-construction phase. Referring to the second line, the scenario where the roadway is widened under a 3R scope of work, a structure must meet minimum 3R standards. In the third line, the roadway is assumed to have a 3R scope of work but is not widened. Assume it already meets the 3R standard width. A road or street structure within the project limits needs to meet or exceed the minimum 3R standard clear bridge width if it doesn't already, if a cost-effective analysis requires it per note 6. Referring to the fourth line, the scenario is that the structure is being replaced or lengthened. If the ADT is 400 vehicles per day or greater, the approach roadway should meet new and reconstructed standards. Structures are built to last 60 to 75 years. The Board of Public Roads would not want a new structure located, for example, on a substandard horizontal curve or a substandard vertical curve. If the ADT for a rural road is fewer than 400 vehicles per day, Note 22 in the standards offers some flexibility in that some design criteria for the approach road need to meet new and reconstructed standards only if a cost-effective analysis requires it. In the fifth line, the assumed scope of 3R work is widening a structure. Note 6 may require that the approach traveled way or paved shoulder be widened if there is a significant relevant crash history related to the roadway width. Referring to the bottom row, if a structure is being improved with a 3R scope of work, but the clear bridge width is not increased, the approach roadway need not meet minimum 3R standards, unless there is some other reason, such as a new guardrail installation. Finally, don't forget about State Statute 39-2101. It requires roads and streets eventually to be brought up to reconstructed standards. This slide demonstrates by an example what is required for roadway work if a structure needs 3R work and part of the scope is to widen the structure. It is an 18-foot bridge with a 3R scope of work requiring widening to 22 feet. The existing traveled way is 18 feet. The minimum 3R standard lane width is 10 feet. Therefore, the minimum standard traveled way is 20 feet for a 2-lane road. The question is, do standards require the approach roadway to be widened? In this example, standards would not require widening the roadway unless a cost-effective analysis per note 6 on page 47 requires it, or there is something else which causes the roadway to meet minimum design standards. For 3R work, note 6 requires a review of crash history, and if that review results in a significant relevant crash history related to travelway width, then widening the approach roadway would be necessary. Of course, since the bridge is being widened, part of the scope is likely to include approach guardrail, so that part of the approach roadway will need to meet 3R standards, and thus be required by standards to be widened. If there is a relaxation of standards request for clear bridge width in this case, the board may be interested in why neither the road nor the bridge are being brought up to minimum standards. If 3R work on a structure only involves improving or maintaining the structural capacity, the intent of the Board of Public Roads is that the scope by itself does not require any work on the approach traveled way. In other words, the board does not expect any relaxation requests for roadway work if all that is being done is to shore up the structure. However, Note 6 requires a cost-effective analysis to be done for 3R work. If there is a significant crash history related to clear bridge width, standards may require widening the structure depending on the outcome of the benefit-cost analysis. Note 20 on page 54 of the standards provides that a timber bridge under certain conditions can have its superstructure replaced in kind under maintenance standards. The conditions are that the National Functional Classification is local and the ADT, or traffic volume, is fewer than 400 vehicles per day. A superstructure is the portion of the bridge that supports the deck and is supported by the substructure. In kind means using the same or similar materials and building to the same dimensions, length, and clear bridge width. A reminder, replacing in kind may involve the practice of engineering. See State Statute 81-3421. If an in-kind timber superstructure replacement is done under maintenance standards and it costs more than the statutory threshold, currently $109,000, the reference statute is 81-3445. It does not necessarily relieve the political jurisdiction of the responsibility or possibly the legal requirement to hire a Nebraska licensed engineer. Note 21 on page 54 of the standards addresses low water stream crossings and fords. These are defined on page 44 of the standards. A low water stream crossing passes normal stream flow below the driving surface, but is normally overtopped with water at least once annually. Low water stream crossings are man-made structures as shown in the photo. Stream fords are considered mostly a natural phenomenon. Low water stream crossings and fords may be used in certain circumstances, in particular when flows are flashy, meaning that they come and go relatively quickly, such as ephemeral streams, or the stream has a low base flow. Traffic volumes are very low, delays are acceptable, the stream channel is broad and flat, and it is the least cost alternative. There are many considerations, including the passage of aquatic organisms. For rivers and streams that convey large flows, bridges and large culverts are better suited. Low water stream crossings and fords are not appropriate for many situations, and their application is limited. Because low water stream crossings and fords may be frequently overtopped by flooding, they have a certain amount of risk and are generally not recommended. That is why any low water stream crossing or ford needs to be brought to the Board of Public Roads and be granted a relaxation of standards prior to construction. The NBCS minimum design standards allow low water stream crossings or fords to be built only on some county roads and only under certain conditions. The conditions are the road cannot be the only access to an occupied dwelling. The state functional classification must be minimum maintenance or local, and the ADT must be fewer than 50 vehicles per day. As mentioned on the previous slide, a low water stream crossing or ford must get a relaxation of standards granted by the Board of Public Roads before being built. New low water stream crossings or fords shall not be built on county roads with state functional classifications of other arterial, collector, remote residential, or scenic recreation, or, as already implied, on roads classified as local and with an ADT of 50 vehicles per day and greater. The next segment is a review of the information presented, including some quiz questions. The two videos for bridges and structures presented definitions, length, bridge, and non-buried structure, notes 6 and 18 through 22, and 3R requirements in the 2016 Minimum Design Standards for County Roads and Municipal Streets. Let's do a review. When it comes time to answering a review question, you have the option of pausing the video before the answer is given. The next two slides review the type of work with respect to bridges and structures. The question is, how would you distinguish between new and reconstructed work and 3R work? For the answer, it will be easier to define new and reconstructed work and then define 3R work relative to that. A new and reconstructed structure is A, new, B, replacement of an existing structure, or C, lengthened along the center of the road. Replacement means the foundation, substructure, superstructure, and deck, the entire structure. Another phrase you may hear for lengthening a structure is adding a jump span. A jump span is an extension at the end of an existing structure, necessitated usually by a flood event or events, which severely scour an erodible embankment at the structure. Now that we know what new and reconstructed work consists of, we can simply say that 3R work involves a scope of work less than new and reconstructed. Examples of 3R work are bridge rail and guardrail upgrades, replacement of the superstructure, extension of culverts perpendicular to the road, redecking, widening, and thin Portland cement concrete overlays. The question is, how would you distinguish between maintenance work and 3R work? For the answer, it will be easier to define maintenance work and then define 3R work relative to that. For maintenance work on structures, refer to page 89 of the minimum standards. Maintenance work is defined in the standards by a list of activities: cleaning, painting, repairing, in-kind replacement of rails, floors, stringers, piling, and beams, but nothing extensive or costly. Rotted timber piling can be replaced with steel piling. Now that we know what maintenance work consists of, we can simply say that 3R work involves a scope of work more than maintenance work. To summarize this slide and the previous slide, 3R work is any scope between new and reconstructed work and maintenance work. This slide and the next slide pose specific questions related to the type of work. Question 1. When upgrading the approach guardrail to an existing bridge, the lane and shoulder widths of the approach roadway must meet minimum new and reconstructed standards. True or false? The answer is false. Upgrading guardrail is a 3R activity. See page 38 of the standards. Therefore, the approach lane width and shoulder width must meet minimum 3R standards. If the existing bridge meets the new and reconstructed standard clear bridge width, it would be prudent for the approach lanes and shoulders to also meet new and reconstructed standard widths. However, that is not a minimum requirement of the minimum design standards and would be considered more of a best practice. Question 2. A culvert under a road is replaced, and therefore the approach roadway must meet minimum new and reconstructed standards. True or false? The answer is true. Culvert replacement is a new and reconstructed type of work. See page 37 of the standards. Therefore, the approach lane width and shoulder width must meet minimum new and reconstructed standards. Question 3. When adding a jump span, what standards apply? The answer is new and reconstructed standards apply to a jump span. To review, a jump span is an extension at the end of an existing structure necessitated usually by a flood event or events which severely scour an erodible embankment. Question 4. When replacing the superstructure of a steel girder bridge, what standards apply? The answer is 3R standards apply. Replacement of a superstructure while using the existing substructure is a 3R activity. See page 38 of the standards. Note 18 on page 53 indicates that it is desirable to meet new and reconstructed clear bridge width. The word desirable does not indicate a requirement, only that it is a preference. This slide is a summary of notes related directly to bridges and other structures. Refer to pages 47 through 54 of the standards. Note 6 is for 3R work specifically. It requires checking crash history to see if clear bridge width is a cause of crashes. The term used in the standards is cost-effective analysis, and a crash history is part of that process. 18 and 19 on pages 53 and 54, respectively, are the main notes for structures. Note 18 on page 53 covers clear bridge width, which is calculated by the simple formulas A through H in the note, but cannot be less than the applicable value in the table without a relaxation of standards. Note 18 also provides minimum requirements for structures if the roadway or paved shoulders on either side are widened or reconstructed. In those cases, the structure must at least meet 3R standards. Note 19 on page 54 covers structural capacity minimum standards. Note 20 allows for certain timber bridges replacement of the timber superstructure with an in-kind timber superstructure under minimum maintenance standards. Note 21 provides conditions and requirements for low water stream crossings and fords. And finally, Note 22 on page 54 provides minimum requirements for the roadway and roadside on either side of a structure replacement for very low volume roads when rural area standards apply. Now for some quiz questions on the notes. Question A. Note 18 applies only to bridge-sized structures, length over 20 feet. True or false? The answer is false. Note 18 applies to structures 4 feet and longer, to non-buried structures and bridges. Question B. The width of paved shoulders has no effect on the minimum clear bridge width of an adjacent structure. True or false?
True or false?
The answer is false. Note 18 requires checking the sum of the traveled way and paved shoulder widths because if that sum exceeds the width calculated by the applicable formula A through H, or the width in the table, it must be used as the minimum clear bridge width. Question C. An existing structure must meet minimum new and reconstructed clear bridge width if the roadway is reconstructed. True or false? The answer is false. Although it would be desirable to meet new and reconstructed clear bridge width, Note 18 sets the minimum requirement of 3R clear bridge width if the adjacent roadway is widened or reconstructed. For these situations, the Board of Public Roads felt it was better to set the minimum requirement to take advantage of structures that have remaining life. Of course, these are minimum standards and it is up to the county or municipality to decide if a replacement would make more sense for the given situation.
Question D. Note 20 allows any timber superstructure to be replaced with any type of superstructure as a maintenance activity. True or false?
The answer is false. The road must have a national functional classification of local, an ADT of fewer than 400 vehicles per day, and the replacement superstructure cannot be just any type. It has to be replaced in kind, which means the same or similar materials and dimensions.
Note 20 applies only to bridge-sized timber structures, those with an opening of 20 feet and longer as measured along the center of the road. Question E. As long as a low-water stream crossing project is on the 1 and 6 year plan, the county can go ahead and build it. True or false?
The answer is false. Note 21 on page 54 requires the Board of Public Roads to review design documents and approve prior to construction.
Question F.
H.
When replacing a structure on a very low volume road, less than 400 vehicles per day, where rural area standards apply, a substandard horizontal curve must be corrected. True or false?
The answer is, it depends. Note 22 would require the curve to be brought up to standards only if there is a significant crash history related to or caused by the deficient horizontal curve, and a cost-effective analysis indicated that user benefits are greater than the cost of correcting the curve.
This is a reminder of the 7 structure-specific learning objectives established at the outset of this 2-part video.
They include the tables and how they work for bridges and other structures, the 2 design criteria for structures and the bases for their values, how the scope of work on a road or street can potentially cause work on a structure, and how work on a structure can potentially cause work on a road or street, and finally, low water stream crossings and fords.
Question 1.
When could work on a roadway cause work on a structure? The answer is reconstructing or widening the traveled way or paved shoulders on a road or street adjacent to a bridge or other structure requires the bridge or structure to meet or exceed 3R standards, possibly adding to the scope of work for the project. Question 2. The minimum structural capacity of all new and reconstructed bridges, non-buried structures, and culverts is HL93. True or false? The answer is true. HL93 is the minimum structural capacity requirement for all new and reconstructed structures. Question 3. Widening a bridge is a 3R activity. True or false? The answer is true. Widening a bridge is considered a 3R scope of work. See page 38 of the standards. Question 4. Resurfacing the deck of a structure is a new and reconstructed activity. False? The answer is false. Resurfacing the deck of a structure is considered a 3R scope of work. See page 38 of the standards. Question 5. Clear bridge width values depend on traffic volume. True or false? The answer is true. See any of the first 12 tables, pages 55 through 78. Question 6. If a road or street is widened where a buried culvert exists, the road or street width must meet or exceed 3R standards. True or false? The answer is true. See note 18 on page 53, the paragraph in bold font, second sentence. Question 7. A low water stream crossing or ford can be constructed on a very, very low volume road if it is the only access to an occupied dwelling. True or false? The answer is false. See table O on page 79 and also note 21 on page 54. It cannot be the only access to an occupied dwelling. Question 8. For low water stream crossings and fords, what is the one required piece of information, in addition to the other usual information, to be included in the relaxation of standards submittal to the Board of Public Roads? The answer is that the road is not the only access to an occupied dwelling. Question 9. If work more than maintenance is done to strengthen a bridge, the bridge must be widened if its clear bridge width does not meet the 3R standard. True or false? The answer is true. The bridge must meet all 3R standards if work more than maintenance is done, or a relaxation of standards must be granted by the Board of Public Roads. Question 10. A new or replacement 36-inch corrugated metal pipe culvert under a road or street must meet the minimum design standard for structural capacity, HL93. True or false? The answer is true. The minimum standards for the structural capacity criterion are not a function of opening size or length. Refer to note 19 on page 54 and the tables from page 55 through 86. Question 11. What is the minimum clear bridge width for a replacement bridge on a rural 2-lane county road with earth shoulders, classified as minor collector with 12-foot lane widths and an ADT of 550 vehicles per day? The answer is 30 feet minimum clear bridge width. The national functional classification is minor collector in a rural area. Therefore, the correct table is table I, starting on page 67, and the bridge standards are on page 68. A replacement means that the type of work is new and reconstructed. Looking at table I on page 68, an ADT of 550 vehicles per day is in the 400 to 1499 vehicles per day group, and formula C applies to that group. Note 18 on page 53 indicates that formula C is the traveled way width plus 3 feet each side. The traveled way width is 2 times 12 feet or 24 feet. Adding 3 feet each side makes it a 30 feet minimum clear bridge width according to the formula. The value in the table is 28 feet, which is less than the value calculated by the formula. Therefore, use 30 feet as the minimum clear bridge width. Anything less than 30 feet requires a request for a relaxation of standards from the Board of Public Roads. Question 12. What is the minimum design structural loading capacity for a bridge on a street in North Platte with a national functional classification of minor arterial if the scope of work is a deck overlay? The answer is the original design loading, or if unknown, HS15. The national functional classification is given as minor arterial. North Platte is over 5,000 population, therefore this is an urban area. See page 42 of the standards for urban area. Therefore, the correct table is table C starting on page 55 with the bridge standards on page 56. A deck overlay is a 3R scope of work. See page 38 of the standards for 3R definition. Table C for structural capacity refers to note 19 on page 54. Note 19 indicates that for 3R work, the minimum structural capacity is the original design loading, or, if that is unknown, it would be HS15. This concludes Part 2 of 2 of Nebraska's 2016 Minimum Design Standards for County Roads and Municipal Streets with respect to bridges, non-buried structures, and culverts.